For today's lesson, you will need IC 29. This is the first day of Standard 7, where we are going to be focused on proofs that can use parallel lines in different ways. So our starting point today is to review information from Standard 6, where we learned about the angles formed when a transversal intersects two or more other lines, and then also what is true for those angle pairs when the lines are parallel, like they're indicated in this picture with these little flags. So the first fact that we're going to review is the corresponding angles postulate. This is now going to become a reason in our proof sometimes if we're dealing with a pair of corresponding angles like angle 8 and angle 1, for example. Those are corresponding angles because they are on the same side of this transversal, and then one of them is an interior angle, angle 8, while the other is an exterior angle, angle 1, and they're also in that same corresponding location. So in this little group of angles, angle 8 is the top right, angle 1 is in that same top right position over in its little group of angles. From Standard 6, if these lines are parallel, we learned that the corresponding angles postulate tells us that corresponding angles will be congruent to one another. Moving ahead to alternate interior angles, an example of those would be angle 8 and angle 3. Those are alternate interiors because they're on alternate sides of this transversal, one's above, one's below, and they are in the interior space between our parallel lines. Angle 5 and angle 2 would be a second set of alternate interior angles. Our theorem tells us, again, that if lines are parallel, that's always a requirement, these alternate interior angles will also be congruent. Our third type of angle from Standard 6 was alternate exterior angles. Those would be like angle 7 and angle 4. Like alternate interiors, they need to be on alternate sides of this transversal, so one above and one below, but then they won't be in the interior space between our parallel lines, they'll be in the exterior space. Angle 6 and angle 1 would also be a set of alternate exterior angles. That theorem repeats the requirement that lines need to be parallel first, but if that happens, then alternate exterior angles are the third type of angle that are congruent to one another. Then we get to our fourth and final kind of angle called consecutive interior angles. Those are not alternate. So if we start with an interior angle like angle 8, we need to stay on the same side of the transversal, but also stay in between those parallel lines. So an example of consecutive interiors would be angle 8 and angle 2. We could have also selected angle 5 and angle 3. Those are the ones that behave differently than all of the others. So when lines are parallel, consecutive interior angles are not congruent. Instead, they are supplementary, which means they add up to be 180 degrees, unlike the rest. So what we're going to do is we're going to recycle these 4 pieces of information that we already know from Standard 6, but we're going to use them in a different way now for Standard 7 because these are going to become reasons in proofs. There's one more important piece of information that we need to know, one more important vocabulary idea. We've reviewed this or we've used it one other time already, but it was in some notes where your teachers were proving to you why these theorems and postulates worked. And that property that popped up in those proofs was called the transitive property. So now we're going to officially talk about what that transitive property tells us and a couple of examples of how it can be used. And then we'll be off to start doing some proofs using the information. Transitive property can be used in angle situations or segment situations, but most often we'll see it used in terms of angles. But if 2 angles or segments are congruent to a third, then that tells us that they are also going to be congruent to each other. In English, that sounds a little bit weird. It's not super clear unless you really think through those words very, very slowly. So that's why we have a couple of examples here for us to take a look at. So let's read these examples as we read the words. So if two angles or segments are congruent to a third, so our two angles are going to be angle 1 and angle 3. They are both congruent to angle 5, the one that's underlined. Or over here, our two segments that are congruent would be these two, segment AB and segment CD. They're congruent to a third, segment WZ, that matches. So that's what this hypothesis looks like. That's what that beginning statement requires us to know. We have to have two angles that are both congruent to a third, or two segments that are both congruent to a third. And so then what the property tells us is that those angles or those segments, so angle 1 and angle 3, or segment AB and segment CD, are also congruent. So our conclusion is going to have a congruent sign in it to each other. So these angles that we highlighted are congruent to each other. These segments that we highlighted are congruent to each other. Now let's think about whether or not that makes logical sense. If angle 1 is the same size as angle 5, but then angle 5 is the same size as angle 3, these angles are identical. Imagine that they're both like 100 degrees. Well, that means angle 1 would have to be 100 and angle 3 would have to be 100, so that means angle 1 and angle 3 match. The same thing would be true about segments. Imagine that segment WZ has a length of 10. Well, that means AB has a length of 10 and segment CD has a length of 10, so they have to be the same size as each other. So anytime we're noticing this kind of repeated angle or this repeated segment, that repeated segment or repeated angle is going to disappear, and we're going to create a third congruent statement out of the leftovers. Angle 1 and angle 3 in the first case, or segment AB and segment CD in the second case. So we're going to be on a lookout for the postulates or theorems that we reviewed at the top, as well as the transitive property. And then they're saying we're also going to have some other previous knowledge, so we'll have to see what that is, that's going to help us to complete our proofs. These two proofs have exactly the same diagram, but they have different given information, and they have different prove statements, which means what we know is different and our goal is different. We're just using the same diagram for both, kind of like we did with our congruent triangles. All right, let's go ahead and jump in and see if we can talk about some proof strategy. I'm going to start, like I do with all of my proofs, by thinking through the given information. And we're not writing flowchart proofs for parallel lines because they wouldn't fit very well in our format from our congruent triangles in Standard 5. But I can still read the information and I can still try to think about whether that information would belong in a bubble or in a box. So as I read through, line M is parallel to line N. We know that every given is going to end up written into our proof. So I'm just going to copy it. It looks a little bit weird sometimes, so if you make those parallel symbols a little bit taller than your L's, that helps. Or some people use like a cursive L to make it pop up a little bit better. If I go over to my picture, I don't really see any evidence on the picture that line M is parallel to line N. So I'm going to go ahead and add those little flags that we know should be there when lines are parallel. That information is true because it was given to me. And I feel like if we were writing a flowchart proof, that would be bubble information. Because typically, we take our information and we turn it into congruent sides or angles. This does not have any congruent symbols in it yet. And in fact, congruent symbols wouldn't make any sense because lines go on for forever. So they can't have a particular measure and be congruent to something else. So I'm going to try to think about what could be congruent thanks to those parallel lines. But in order to make a good choice, I feel like I should probably also pay attention to my other given. So although this seems a little bit weird, I'm going to fill in my other given, angle 2 and angle 1, down here in statement and reason number 3. And then I'm going to kind of think about those angles in my picture as I'm considering how these parallel lines might be helpful. So, another piece of information that's going to help us is to pay attention to where we're trying to go. If we're trying to get to the point where angle 3 is congruent to angle 1, but angle 1 has already been talked about in a given piece of information, usually it's a good idea to try to think ahead to where the transitive property might help me out and to try to focus on the other angles that don't seem to be repeated yet. So I'm going to investigate angle 2 and angle 3 in my picture. They're living right here, connected by transversal K, which is really great news, because if line M is parallel to line N, and angle 2 and angle 3 are connected by a transversal for those parallels, I should be able to say something about them using one of my reasons we reviewed up there at the top. So let's try to give angle 2 and angle 3 a name. They would be alternate because they're separated by that transversal, but they would also be interior because they're trapped in between those parallel lines. So if I think about them as being alternate interior angles, that means I'm going to be allowed to use the alternate interior angles theorem from up top to say that angle 2 is congruent to angle 3. That is only true because of those parallel lines. So there might have been other things we could say were true thanks to those parallel lines, but the key is to pick something that's not only true but is also helpful. Remember that goal, because we want to eventually make our way closer to this particular goal, this proof statement, angle 3 congruent to angle 1, not some other random set of angles that might happen if we're not quite as careful. All right, so I've written my parallel lines down. I've used them to talk about some angles that seem related to the other given, which is in row 3, as well as to the proof statement. And then I noticed something really important sitting right here in statement 2 and statement 3. I've got a matching angle, which is exactly what happened up here when we talked about the transitive property. So if we know angle 2 is congruent to angle 3, but angle 2 is also congruent to angle 1, I think we're ready in statement number 4 to make the claim, to write down the statement that angle 3 is congruent to angle 1, thanks to our new transitive property. Now, that is all that's required to finish out this proof, but I will often write a little parentheses after the transitive property to explain which two statements I combine together. That just helps me to make sure I actually had enough information to use the transitive property, because sometimes your brain will try to play tricks on you and get you to use it before you're ready for it. But when I took statement 2 and statement 3, there was a repeated angle there, so that allowed me to make a transitive property statement with the other angles that were involved. That's optional. You don't have to have that, but you'll see me write that down each time I have transitive property, because it helps me to make sure I'm truly ready to use the transitive property correctly. All right, moving on to number 2, we're going to have the same diagram. It looks like we have some of the same given information, so I'm going to go ahead and mark that line M is parallel to line N. I'm going to get that into my proof. Line M is parallel to line N. But then it looks like our next piece of given information is a little bit different. I'm going to, again, leave myself a space here so that I can use those parallel lines for something, but I want to keep in mind that I also have information about angle 4 and angle 5, thanks to a second given. So angle 4 and angle 5. And my goal is to say something about angle 4 and angle 6. So I'm noticing again, I've already covered angle 4. It's in my proof thanks to the given, What's not quite there yet would be angle 6. So if I can try to make a link between angle 5 and angle 6 using a transversal for my parallel lines, that's going to set me up really well for transitive property, just like we did the first time around. So is it possible for us to say something about angle 5 and angle 6? 5 and 6 are on alternate sides of that transversal. If I investigate the interior space, neither one of them is in there. So I think it is possible for me to say that angle 5 is congruent to angle 6, but instead of them being alternate interior angles this time, they're going to be alternate exterior angles this time. Include that word theorem in your reason to make sure it's not just the angle type, but it's actually an official reason. Take a look this time. Do we end up with a set of matching angles like we did the last time? Last time they were up front in both statements. This time they're not both up front, but that's okay. Angle 5 is congruent to angle 6 and angle 4, so we should be able to finish it out and say that angle 4 is congruent to angle 6, thanks to that transitive property again, which is still combining statement 2 and statement 3 together, just like it did in that first proof. So just a slightly different statement based on my parallel lines, because my goal was to focus on angle 4 and 6 versus 3 and 1. All right, go ahead and flip the page over and meet me back here for a few more examples of how we can deal with proofs that involve parallel lines. All right, these next two proofs have diagrams that look a little bit different than the ones on the front side, but we're still going to use our same kind of strategies, carefully thinking about one given at a time. And as I kind of preview what I see here, it looks like I'm going to have a little bit more work to do on these, because instead of one set of parallel lines being given, I actually have two, which means I'm going to need to be a little bit more careful with my statements and my reasons. I'm going to start by making sure we can see that line M is parallel to line N. And then I'm always going to try to use those parallel lines for some congruent angles. So if you want to leave that statement and reason line open, you could go ahead and write your second given down if you would like, but I'm just going to kind of stop for a minute because that second given is really similar and I don't want to get overwhelmed. Take a sneak peek at your goal. The goal is to eventually talk about angle 1 and angle 7. So let's investigate. If I'm looking at line M and N being parallel, I have a choice between using J as a transversal or K. If I use J as a transversal, it looks like angle 1 wouldn't be able to be talked about, but I could say something about angle 7. If I used line K as a transversal, angle 1 is over here, so I would be able to say something about it. So in this case, it really doesn't matter which transversal I choose. I'm going to choose to use J as a transversal, but you could also do this proof correctly if you focused on line K. So thinking about line J as the transversal, I want to make sure that I'm saying something about angle 7. Angle 7 uses line M, so if we slide down that transversal, the goal would be to either talk about angle 7 and angle 5, or angle 7 and angle 6. And I think either one will work. If we looked at angle 7 and angle 5, those would be alternate interiors, so we could say those are congruent. Or if we used angle 7 and angle 6, those would be corresponding angles, so they would also be congruent. So sometimes there's multiple ways to do the same proof. It doesn't mean that one way is more correct than the other, it just means they're different approaches. I'm going to go ahead and go with 7 and 5 for this one, which means angle 7 congruent to angle 5 will be my statement, and alternate interior angles theorem will be my reason. Now that that's taken care of, I used my parallel lines M and N to talk about some angles. So I'm going to pull in my second set of parallels. Line J is parallel to line K, which is also given, to hopefully talk about some other angles. Add some parallel line flags onto the picture. And it looks like, again, I have two choices for a transversal. I could talk about line M, or I can talk about line N as the transversal. But let's make sure we make a really good choice between those two. Remember, our goal is to talk about angle 1 and angle 7. I've already talked about angle 7, so I feel like my next statement needs to talk about angle 1, otherwise I'm not making progress towards my proof statement. So if I need to talk about angle 1, that makes the decision for me about what needs to be the transversal. I have to focus on line N because that covers or passes through line J and line K, which are my new parallels I'm trying to use, thanks to statement number 3. Now, in addition to wanting to talk about angle 1, it would be really great if we could make a link so that the transitive property would be there. So if I've already talked about angle 5, and that's on the same transversal as angle 1, I feel like that would be the best option for my new statement number 4. The question is, how do I know that angle 1 is congruent to angle 5? They're on the same side of that transversal line N. Angle 1 is an exterior angle and angle 5 is an interior angle. Those fit the description of our corresponding angles, which, if we're turning that into a reason, needs to have the word postulate attached to it. Okay, so let's see if I've done what I need to do. I've got parallel lines turning into angles, more parallel lines turning into more angles, and if I investigate these two congruent statements, I do have a pair of angles that I talked about twice. So if angle 5 is congruent to angle 7, and angle 1, then that means I know angle 1 is congruent to angle 7, thanks to my transitive property again. Now this time, if we want to describe where that information came from, it wasn't lines 2 and 3 that got combined. It was actually statement 2 and statement 4 that we combined together. Thanks to that angle 5 that was repeated, angle 1 and angle 7 turned out to be congruent. All right, one more chance to practice that same type of a situation. We have two sets of parallel lines, so we're going to think very carefully about one set at a time. Line M is parallel to line N, is our first given. So go ahead and put some flags on those, and then try to think ahead to which angles we want to talk about, keeping in mind that angle 2 and angle 6 are the ultimate goal. So if I stayed consistent to before and use J as the transversal, it looks like I could say something about angle 6 maybe. But if I wanted to switch it up and use K as the transversal, angle 2 is sitting there ready to go. So I don't think, again, it really matters which one we pick. Let's go ahead and switch over to this K transversal this time, just for fun, which means we need to talk about angle 2 and angle 3 or angle 2 and angle 1, since those are the ones connected by that transversal. If I look at 2 and 3, they're alternate, but 2 is exterior and 3 is interior, so they don't fit any of our 4 new kinds of angles. 2 and 1, however, are going to be corresponding. So those are going to be the ones that I'm going to want to say are congruent for statement number 2, using the corresponding angles postulate as my reason. Okay, so line M and line N being parallel provided me with angle 2 and angle 1. Let's switch now to our second given. Line J is parallel to line K, and see what kinds of angles we can focus on for our fourth statement. J and K should probably have some little flags on them to remind us that they're parallel. They have two transversals, M and N, but last time we were forced to make a choice when we considered what we already knew and what we were trying to prove. So it looks like angle 2 is already covered. I haven't talked about angle 6 yet, and I need to probably repeat angle 1 in order to be set up for transitive property. So if my focus is going to be angle 6 and angle 1, that's going to force me to use line N as the transversal for parallel line J and parallel line K. Double check to make sure we can say something about those two angles. They are alternate and exterior, so we can say that angle 6 is congruent to angle 1 thanks to the alternate exterior angles theorem. Okay, we've got two sets of congruent angles. Angle 2 is congruent to angle 1. Angle 6 is congruent to angle 1. So there's my repeated angle, which means I am in fact ready to go to make my statement that angle 2 from statement number 2 is congruent to angle 6 from statement number 4, just like my proof statement told me to do. So there's our transitive property again, combining statements 2 and 4 together to create that new set of congruent angles, where angle 2 all the way over here in the picture is congruent to angle 6 all the way over there in the picture. We couldn't have proved that any other way because they're not connected by a transversal, so we wouldn't have been able to call them any of our other types of angles that we've learned about. All right, 2 more proofs to finish out today's notes. In this last one, it looks like the picture is a little bit different, but we're still dealing with some parallel line segments this time instead of full lines, which is why that looks a little bit different. But segment CD is parallel to segment BE. It looks like I have 3 choices for transversals, 1, 2, 3, that would connect them. But if I pay attention to the other given and where I'm headed, it looks like angle 3 is already covered, and I probably want to say something about angle 1 and 2, which would focus me in on that transversal there in between B and D. If we're looking at angle 1 and 2, they are connected to our parallels. They are connected by a transversal. They are alternate interior angles, so we are able to say that they're congruent thanks to the alternate interior angles theorem. So once we use those parallels to talk about that set of angles, we're going to bring in our second given. We already know angle 1 is congruent to angle 2, but we also know angle 1 is congruent to angle 3. So I see, for the 5th time today, a pair of angles that are repeated. Forgot to write my reason down as given. So I'm ready and set up to use my transitive property. If angle 1 is congruent to angle 2 and angle 1 is congruent to angle 3, then I'm ready to write my proof statement down that angle 2 is congruent to angle 3 thanks to the transitive property, combining the information this time in statements 2 and 3 together. So a little bit of a different picture, but the same type of thought process that we've been using for the others. And I bet number 6 will be really similar. So if we start working through this one, we've got segment BC parallel to segment AE. So segment BC up top is parallel to segment AE down here at the bottom. It looks like, again, that we would have 3 different transversals possible. So rather than just randomly picking one, let's look at what we've got available to us in our given and our proof. Looks like angle 6 is present in both, so let's focus in on angle 1 and angle 4, which forces us to use this transversal here. This one is a little bit trickier to see, so I'm going to go ahead and highlight those parallel segments a different color. Hopefully that helps angle 1 and angle 4 to pop out a little bit better for you visually. Those are alternate interiors again. So we're going to have another opportunity to talk about those 2 angles as being congruent using our alternate interior angles theorem. So we've used those parallel lines for some congruent angles. let's go grab our other given that talks about angle 6 and angle 1 being congruent. And sure enough, just like we've seen every other time today, we've got angle 1 that shows up in that proof twice. If angle 1 is congruent to angle 4 and angle 6, we are ready to say that angle 4 is congruent to angle 6 one last time, thanks to that new transitive property. Combining together statements 2 and 3 again to make that last set of angles that matches our proof statement congruent. Now in this picture, you might look at angle 4 and angle 6 and be like, wait a minute, did I really need to do all that work? Aren't those corresponding angles? And you would be right. Those are corresponding angles. However, in order for those angles to be congruent, we would have needed to know that BD that passes by angle 4 was parallel to CE, and that was not in our information. So we don't want to just look and assume they're going to be congruent when we're not given the parallel lines that we would need, which is why all this other effort using the parallel lines that we did have, as well as some givens and our transitive property, will help get us to that proof statement. All right, that's it for today. We'll see you back in class. Thanks for watching.